Hello, everybody. Welcome to today's lesson. My name is Pathman Math, and today we're going to be doing something different from what we've been doing lately. So, quick recap. Last week we went through multiplication tables. Week before, we did common denominator dealing with fractions. This week, as per a request from a subscriber, I am Joe Nielsen. Thank you. We are going to be covering logic and patterns. Now, this is going to be a two-part lesson because there are two big patterns that we are going to be covering, which I will talk about in just a moment here. So this is logic and patterns part 1. Now, what I mean by logic and patterns. Patterns deal with a sequence of somethings that follows a specific rule. It is governed by that rule that we are going to find. Okay? Now, these patterns, this rule, what we are going to try and do is using logic, using our deductive reasoning, being detectives here, we are going to then find what this rule is and figure out how this pattern is governed. Okay? Now, there are two big patterns I'm going to cover. There's different types of patterns. I'm going to be focusing on two different ones. Okay? We've got numeric, hard to write here, slash arithmetic. So you may hear both names for these types of patterns. Now, numeric slash arithmetic, that focuses on numbers, hence numeric. It is a series of numbers that follows specific types of mathematical operations to go from number to number to number to number to number. Okay? Now, the other one that we're going to be covering in the next one, we're going to be focusing on numeric slash arithmetic here in part 1. Part 2 is going to cover geometric. And geometric is dealing with shapes and objects that have something done to that specific shape or amount of shapes, okay? Whether it is increasing the amount of sides that the shape has or increasing the quantity of the shape that we currently have. So say you have a bunch of triangles and you go from a certain number of triangles to a certain number of triangles, a certain number of triangles, doing that, or you start out with a rectangle or square, and then you add more sides to that shape and start increasing the amount of sides, changing it from one shape to the next. That's the type of patterns you can see with geometric. But today's lesson, we are going to be covering numeric slash arithmetic. Okay? So, these rules, these laws that govern the pattern, follow a specific type of layout, dealing with a specific equation. Now, an equation that we're going to be working with deals with variables. Now, variables are letters that we, as the problem solver here, as the mathematicians, that we assign these letters to a specific value, to a specific number. Okay? So, typical ones you'll see is X, Y, Z, A, B, C. And the more values that you don't know for a specific problem, the more variables you will need to solve for. Now, typically, X and Y and Z are ones that will constantly change. A, B, and C are usually just constant values placed at certain parts of the equation that don't change, but change what the final value is going to be. So the equation that we're going to be looking at falls into this layout here of y equals a times x plus b. With the patterns that we're going to be looking at, our value for y is going to be the next number of our pattern, where x then is the current number of our pattern that we are looking at. And then we've got a is what is called the scale or factor that is applied to our current number that helps us then get to our final value, our next number of our pattern. And then b is our pattern constant. This number here is not attached to a changing value in the x here, so it is a constant value. It does not change at all. The scale is also a constant value, but it's applied to a different number each time that we work our way through the pattern, so it winds up changing a little bit because it's being multiplied. So this is our equation. Y equals ax plus b. Y is the next number of our pattern. X is the current number of our pattern. A is our scale. B is our pattern constant. And this is how we structure our rule that governs the specific pattern we are looking at. Now, in order to find the different values here, particularly A and B, because X and Y are given to us by the pattern we are looking at. Okay? X and Y are given to us by our pattern. We need to find what A and B are, and the way we do that is by using two different pairings of numbers. Okay? We start off by pairing the first value and the second value of the pattern together, plugging them into our values here for X and Y, and then we solve for A to create its own little separate equation. Then perform a few steps there, and we use the second pair of numbers, in this case the second value of our pattern and the third number of our pattern, to then solve for B. Once we get what B is, we take it, plug it back into the little equation we create for A, we solve for our scale, and then we can then plug our scale and our pattern constant into the equation, and we get our equation, we get our rule that governs the pattern. Okay? So that was a quick little explanation for what we're going to do. Now I'm going to show you what we're going to be working with. So, erase that, leave the general form here. Now our pattern is going to be 1, 3, 5, 7, 9, dot, dot, dot. Once we find our pattern, it continues on. So I'm going to just do dot, dot, dot here. So to start off, we are going to be using 1 and 3 to then create an equation for A, like I said. So Y is our next number, and we've got A times 1 plus B, because X is our current number. We're starting with 1, and we're trying to get to 3. Now, remember from last week, when you multiply any number by 1, it's going to still be that same number. So to just clean it up, we got 3 equals A plus B. Boom. We got our next step here. Now, we need to get the A by itself. In this case, what we're going to do is we're going to subtract B from both sides, okay? What you do to one side, you do to the other side, okay? So we cancel out the b on this side, and we're just left with a. Now, because this is an equal sign, we can rearrange the order a little bit, and what we're going to be having here is a equals, and then it's 3 minus b. That is our little equation for finding what a is. Now, in order to find what a is, we need to take this equation, plug it in for a up here, and then we use the next two numbers, in this case 3 and 5. We're going to plug those in, and we're going to solve for b. Okay? So I'm going to write this over here. We got y equals, put it in parentheses because this is a whole thing. This is an equation. We plug this in for a. We got 3 minus b times x plus b. Okay? Now, like I said, we're using the next two numbers, so 3 and 5. So we're going to have 5 equals 3 minus b times 3 plus b. Now, because all of this is on the inside of the parentheses and we're multiplying, we have to distribute 3 to everything. 3 is going to go to the 3, 3 is going to go to the negative b here, because that is technically a negative b. So, 3 times 3, multiplication tables from last week, we got 9. 3 times negative b, you have negative 3 or minus 3b plus b. Now our next step here, we have multiple values here that have b attached to it. Because technically, this b right here is just 1 times b. So, we're going to do what's called combining like terms. Okay? A term is this whole thing right here. That's a term, that's a term, that's a term. We're going to combine the like terms, which is minus 3b and plus b, and we're going to get 9 minus 2b. Now, dealing with negatives gets a little annoying sometimes, can make things a bit extra complicated than it needs to be. So what I'm going to do is get rid of the negative in order to get the b by itself. So plus 2b to both sides, we get 5 plus 2b equals 9. Okay, we got a few more steps here. We're trying to get the b by itself. So I'm going to erase this little section here. Now first, I'm going to make that a bit smaller. I'll rewrite this here. A equals 3 minus b. Making sure we still have a hold of that. Now moving up here, we're going to subtract the 5 from both sides. We wind up having 2b equal to 4, because 9 minus 5 is 4. Now, get the b by itself. We're going to divide both sides by 2, because 2 divided by 2 is 1. We get b equal 4 divided by 2, 2. We have our pattern constant. B equals 2. Now we can take this and plug it in to both here, but we still need to find the scale. So from here, I'm going to take it and plug it in. We have A equal to 3 minus b. A equal to 3 minus 2. That equals 1. Boom. Scale is 1. Pattern constant is 2. Our rule here is y equals 1 times x plus 2. But I'm going to write this a little bit cleaner. Because again, 1 times any number is still going to be 1. So we got y equals x plus 2. Boom. This is our rule. This is our rule that governs this pattern here. Y is the next number. X is the current number. You take 1, plug it in for x. Take 3, plug it in for y. 1 plus 2 equals 3. Boom, we got our two numbers there. 3 and 5. 5 equals 3 plus 2. That is correct. 5 equals 5 on both sides. 5 and 7. Take the 5 in for x, 7 in for y. 7 equals 5 plus 2. Yes, it does. So on and so forth. We have our rule governing this pattern. I know it took a bit more on the detailed steps, but it's the first example. As you start to work with stuff and go through getting more practice for it, it goes a lot faster. And we're going to see that here in the next one. Okay? So, again, y equals x plus 2. We found that from our general equation of y equals ax plus b and using the values of our pattern. You can use this to find more, and it's just going to be 7 and 9 going forward. And then what we can do is take our current value to find the next one, 9 in for x. 9 plus 2 equals 11. The next value is going to be 11. We take 11 in for x, 11 plus 2, y equals 13. That's our next one. So on and so forth. Easy peasy. You just got to make sure you keep track of your mathematical operations. All right, next one that we're going to do, bit trickier, but we have our basics down. So we're going to be able to get through this real quick. So we've got 1, 4, 10, 22, 46, ... We've got y equals ax plus b. And again, we're going to be using the first two values of our pattern, 1 and 4. So we got to find what our a is. We got to find a little equation for our a before we can find our b. So I'm going to plug in our 4 for y, because that's the next value. And then 1 in for x. I'm just going to write it as a. But that's basically just a times 1. But a times 1 is just going to be a. Now we got to get the a by itself. Subtract the b from both sides. We got a equals 4 minus b. Okay? Now, we've got our a. We're going to plug that in up here. And we get y equals 4 minus b times x plus b. Now we use our next two numbers. We're going to use 4 for our current and 10 for our next value. We got to find what b equals. So 10 equals 4 minus b times 4 plus b. Distribute across the board. So we got 10. We got 4 times 4. That is 16. We have negative b times 4. That is negative 4b plus b. Okay. Now, remember, we need to combine like terms. We've got too many times that there's a b there. We got to combine like terms and then work our way down to getting the b by itself. So this is negative 4b plus 1b. We got 10 equals to 16 minus 3b. Boom. We're working this through real quick now because we have the basics. We figured out what to do in the last one. We can then just recreate this. Now, I want to get rid of this negative here. Okay? I want to get rid of this negative. So I'm going to add 3b to both sides. And I'm going to then get 10 plus 3b equal to 16. I'm going to subtract 10 then from both sides. And we get 3b equal to 6. Now, running out of room here a little bit. I'm going to move this up over here. And I'm going to do 3b equal to 6. Get the b by itself. Divide both sides by 3. 6 divided by 3, we get b equal to 2. And yes, I did say 2. Accept it. B equals to 2. So much 2. But right there, some bigger values, but we have a pattern constant of 2. We can now take this pattern constant and plug it in over here for our A, to get our A. So I'm going to erase that little section, and I'm going to plug this in over here. We're going to have an A equal to 4 minus 2. A then equals to 2. We now have our scale. We have our pattern constant. And what we're going to do, clear the board a little bit. Rewrite this down here. And now we're going to plug in our values up here. And we're going to get y equals 2x plus 2. We now have an actual scale rather than just 1. We have an actual scale that we are multiplying to the x. And now we can test this. First two values. In this case here, it's going to do one value at a time. Take a 1. So y equals 2 times 1 plus 2. 2 times 1 is just 2. We get 2 plus 2, 4. Boom. Check. That's a horrible check mark. There we go. That's a bit better. Okay. Now we're going to take 4 and plug it in for x because that's our current one. So y equals 2 times 4 plus 2. 2 times 4 is 8. 8 plus 2 is 10. Boom. We got our next one. Now we're going to use 10 to confirm this. So 10 in for x. Y equals 2 times 10 plus 2. 2 times 10 is 20. We had 20 plus 2. We had 22. Boom. That's a check. 22 in for x. 2 times 22, that's 44. 44 plus 2, that's 46. Now we can take 46, plug it in here, and find our next value. Y equals 2 times 46 plus 2. You get y equals 2 times 46. That is going to give us a big ol' 92, because 2 times 6 is 12. 2 times 40 is 80. 80 plus 12 is 92. Plus 2, we get y equal to 94. That is our next one here. And it's just going to continue to go on, so forth. But we have our rule. Y equals 2x plus 2. That is our pattern. That's our rule for our pattern there. And because, excuse me, because we did the first one with all the detailed steps, we were able to do this one a little bit quicker, and we wound up getting this equation. Boom. We just worked through on numeric patterns. Now, you can do these same exact steps here on any pattern, any numeric pattern, and you're going to figure it out. Okay? So you start off with your y equals ax plus b. You get the a by itself by plugging in the two first values in. Plug in the second value in for y, first value in for x. You solve for a to get yourself a little equation there. Once you have that little equation for a, you plug it back into the original equation, the y equals ax plus b, but now you have y equal to a small equation here for a times x plus b. You distribute, okay? We use our next two values, the 4 and the 10. We plug those in, you distribute, you perform your rest of your operations, you combine your like terms, you then figure out what b is to get your pattern constant. Once you get your pattern constant, plug it into your a, plug it into the value for a there, so you can get what your scale is on your x. Once you have that, you have your scale, you have your pattern constant. Plug them in for the two values that they're representing, and you get your equation. Quick and easy, takes a little bit of practice, but it is good, and it does not take that long to get the hang of it because it's just a bunch of plugging in values, performing the correct mathematical operation. Okay? As you start to work on your practice here, take it a bit slow. You don't want to skip steps. It happens. And things can wind up looking a bit crazy. But the big thing is once you have your rule here on your pattern, test it. Make sure that it works. Okay? One number at a time, you take your first value in, plug it in. Then you take your second value in, plug it in, and work through a few times. Make sure that it tests true. It's not it working through it, taking a look at it the first time can be maybe a little overbearing, but it does not take long to be able to get the hang of it. It's just a bunch of plugging values in, perform the correct operations. You've got it. So that was numeric patterns, dealing with numbers, dealing with patterns of numbers, and finding the rule that governs that pattern. Next week, on part 2, we will cover geometric patterns, dealing with some shapes, dealing with increasing either the sides of the shape or increasing the quantity of the shape. We're going to go through both types of examples for it, but that will be on part 2. That will be for next week. I hope you all enjoyed this lesson. I hope that it helped. I know, again, I could talk a little bit too quickly, but I hope you guys are able to understand what I'm saying here. Hopefully, I'm breaking it down a little bit easier for you, and I hope that you are just enjoying yourselves, getting a different kind of approach to these different subjects. I hope they benefit you, and I hope you keep coming back for more. I am Pathman Math. Thank you for watching this video. I hope you enjoyed the lesson, and I will catch you all in the next one. See ya!